Hello learners, the topic of today's class is electrolysis. So have you ever wondered how does a goldsmith polish gold and silver items making the old items new and shiny? Well, it is based on a simple chemical phenomenon called electrolysis. Electrolysis is the process of decomposition of a chemical compound in aqueous solutions or in molten state accompanied by a chemical change by using direct electric current. So in this, we are decomposing a chemical compound into its constituents with the use of a direct electric current. In order to understand the topic, we should be able to know these three key terms. First is called as electrolytes. So electrolytes are the compounds which either in aqueous solution or in molten state allow electric current to pass through them. So electrolytes are able to allow electric current to pass through them, whereas the non-electrolytes are the compounds which neither in the solution nor in their molten state allows the electric current to pass through them. So this is the key difference between these two. Next comes electrolytic dissociation. Electrolytic dissociation is the process due to which an ionic compound dissociates into its ions in the fused state or in aqueous solution. The electrochemical cell. An electrochemical cell, it is used to convert the chemical energy into electrical energy. So the examples are simple voltaic cell and Daniell cell. So whatever the kind of cells that we are seeing around our day-to-day life, they have a chemical substance inside them that helps us to convert into electrical energy. You might have seen the cells of the remotes of various devices, etc. Next topic to understand is electrodes. Electrodes are the two metal plates or wires, or graphite rods you can say, or gas carbon rods which are immersed in electrolyte through which the current enters and leaves electrolytic cell. You might see this diagram. It is being labeled. There are two electrodes. One is anode, which is positively charged, and cathode, which is negatively charged. They're connected to the battery. And this is making an electrolytic cell. A complete process involves the electrolyte, the electrodes, the battery, the flow of current through the wire. In order to understand anode and cathode better, anode is connected to the positive terminal of the battery. The ions migrate to anode because, as we know, that anode is positively charged, so it attracts the negative ions, which are the anions, towards itself. On this, oxidation takes place, whereas cathode is connected to the negative terminal of the battery and cations migrate to cathode. Reduction takes place here. Next topic that we have to understand is anions. In order to get greater clarity, we should be able to know what exactly are ions. So, the atoms or groups of atoms which carry a positive or negative charge are referred to as ions. The charge on an ion, positive or negative, is the valency of the atom or ion. Anions are negatively charged. They migrate to the anode during electrolysis, lose electrons to the anode, and get oxidized to become a neutral atom. For example, PO4 3- and Cl-. Likewise, cations, on the contrary, are positively charged and migrate to cathode during electrolysis, gain electrons from the cathode and get reduced to become a neutral atom, and the examples are Na positive and Ca2 positive. Here on this slide we can see the electrolysis of lead bromide. So the ions present here are Pb2 positive and Br minus. From the diagram we can see that we have an electrolytic solution and we have two ions being shown in the diagram. There are two rods which are the electrodes. One is the graphite cathode, another one is the graphite anode. And the process is happening. So at cathode, Pb2 positive plus 2 electrons give Pb, and Br minus 1 electron gives Br. We also have to understand the electrolysis of acidified water. From the diagram, you can see 2 volumes of hydrogen are achieved at cathode, whereas 1 volume is achieved for oxygen. Acidified water is water plus dilute H2SO4. So we are doing electrolysis, we are converting water into its constituent, that is hydrogen and oxygen. So at cathode, H positive plus 1 electron gives H, 2H combines gives H2, OH minus on the anode undergoes a reaction in which we get OH plus 1 electron. Likewise, 2 OH combines, they form water and 1 O. 2 O combine to form O2, and the overall reaction goes 2 water plus electrical energy to give H2 plus O2. Since here you can say we have 2 H2 and 1 O2, we say the volume formed of hydrogen is double to that of oxygen. Electrolysis of copper sulfate is shown in this slide. We can see it much more clearly now. Electrolysis of copper sulfate solution using platinum electrode could also be seen on this slide. We can see 2 electrodes and the electrolyte solution, which is copper sulfate in this case. Likewise, we can make the 2 different equations, one at cathode and another one at anode. Based on the ease with which atoms of metals lose electrons to form positively charged ions, the metals are arranged in series, which is referred to as electrochemical series. Since we started with a question about how goldsmiths are able to polish the surfaces of old ornaments, we do it with the help of electroplating. Electroplating is a further extension of electrolysis process in which we have a thin film of metal like gold, silver, nickel, chromium, which is deposited on another metallic article with the help of electricity.